Eclipse is an integrated development environment, IDE, specifically for Java. Basically, it is a good text editor having great set of features like compiler, debugger, syntax autocomplete. Eclipse is often used for Java development. Now, as part of this hands-on exercise, let's try to build our Mapreduce code with Eclipse. First step is to download and install Eclipse. Open eclipse.org, click on download on the top right. Download the one suggested for you. Wait for it to complete. Once downloaded, please double-click to extract and then open the Eclipse installer binary. In Mac, the name of program has suffix .app, and in Windows, its extension is .exe. With installer, install Eclipse IDE for Java developers. Wait for it to complete and then launch. The Eclipse prompts for selecting the workspace. Your work gets saved in a workspace. Close the welcome window. Now let's download the code from GitHub repository. Please open the repository URL displayed on the screen. Click on Clone or Download and then click on Download zip. Unzip the downloaded file. It would have the folders containing the code. In Eclipse, create a Java project. Give it a name. Uncheck the default location and browse to hdpexamples Java folder. Click on Finish. This would create a project. Right-click on it and click on Properties. Select Java Build Path and then select Libraries tab. It has automatically added libraries from lib folder. Select Java compiler. Change it to 1.7 instead of 1.8. It is always good practice to compile your code for a lower version so that your program can run in many environments, because a lower version can run in a higher version of Java virtual machines. But if your code is compiled for 1.8, it may not work on Java virtual machines running 1.7. Click on OK. In the directory structure, you can see it has discovered all the classes. Let's take a look at the driver, the entry point for our example. Now, right-click on the project folder, click on Export, and then select jar file. Next, select the destination. We are going to keep it in the Downloads folder. For now, let's ignore the warnings. The jar file has been created. Now let's upload to CloudX Lab console. The easiest way is to first upload it into HDFS using Hue, and then copy it to the local using Web Console. Open Hue, click on File Browser, and then click on Home just to ensure that you are in your HDFS home folder. Click on Upload, select the file to upload, and let it finish uploading. Now, log into Web Console. To copy the jar file from HDFS to local, use Hadoop fs -copy to local. Notice that the command is case sensitive. Now, using ls, please check if it has been copied to your local folder. Now, let's execute the Mapreduce for word count using Hadoop jar hdpexample _ eclipse.jar com.cloudxlab.wordcount.stubdriver. Now, since the output folder is already created from our previous execution, let's delete this output folder. Let's try to execute the job again. While the job is executed, let's take a look at the status of job in job browser in Hue. Every job has tasks. Here, you can see there are two tasks, one map and other is reduce. For all tasks, there are attempts. Here, there is only one attempt for mapper because it did not fail at all. Click on the attempt and then logs. You can see that there are three kinds of logs: stdout, stderror, and syslog. The general system logs are displayed under syslog. If you have error statements such as system.err.print in your Java code, those would appear in stderror tab. And if you have system.out.println in your mapper code, they would appear in stdout tab. Let us now go back to the task and then back to the job. Similar to mapper, reducer too has logs. Now, let us take a look at the output. Go to the file browser and home directory in HDFS. If you have too many files, order by date in descending fashion. The first folder would be Java mrout. This is the folder where we configured our job to save output to. Now let's take a look at the contents of the file. The result is tab-separated plain text. The first column is word and second column is the number of times the word has occurred. Browse through the code. You will see the first example called chaining. It shows how to chain multiple jobs together. You can execute this driver from existing jar. The second package is char count, which can compute character frequency in a Hue's data. The third package is custom reader, which provides an example of how to create your custom input format. The fourth package is an example of Hive user-defined functions. The next package in the list is nextword. The nextword provides solution to find nextword recommendations based on Hue's data. Simple word count is just another word count. It can be ignored. Now, you can make your modifications to the code, export the jar again, upload to Hue, copy to local, and then run the Mapreduce job through Hadoop jar followed by fully qualified class name.